whenever you train the same PyTorch model twice and got slightly different results, even though you didn't change a single line of code. Yeah, that's not a bug, that's randomness. And if you don't control it, you'll never get a consistent experiments. So today, let's talk about randomness and reproducibility, what causes it, and how to control it in PyTorch. Randomness shows up everywhere in deep learning, from weights initialization to data shuffling to dropout. When you start training, PyTorch uses random numbers to initialize weights, augment data, and decide which neurons to drop during training. That randomness helps your model to generalize better, but it also means two runs can give slightly different results. And if you're debugging or comparing experiments, that's a nightmare. Let's have a look at this with example. So I'm going to create a notebook and I'm going to name this randomness tutorial.ipynb. And first thing we should do is import torch. And as always, let's check the version of our torch. So torch.version, it's same 2.9.0 with CUDA support. Now let's create our tensor using rand function. So I'm going to say x equals to torch.rand. And let's have a look at our x. So nothing fancy. This is a vector with 3 elements and it's a tensor. Let's create this tensor again, or actually rerun this. You see that tensor value has changed. So notice both run gives different random numbers. This is expected because the random generator starts from new state every time. Now imagine the same thing happening when you initialize millions of weights in a neural network. You'll never get the same accuracy twice. So to make experiments reproducible, we use something called a seed. Think of it as the starting point for your random number generator. If you give it the same seed, you get the same sequence of numbers or random numbers every single time. Let's have a look at the example. So I'm going to say torch.manual seed and I'm going to set 42. And instead of 42, you can give whatever number you want and you'll get the same sequence every single time. I'm going to show you with another example as well, but let's run this and let's generate the number again. So torch.ran3, you get this response. I'm again going to set this torch.manual seed to 42. And let's recreate this tensor. You get the same response. So that's how you can reproduce your results. You can see now both outputs are identical. That's the power of reproducibility. Same seed, same randomness, same results. Now imagine you're training a real model. So in the real training pipelines, you use multiple different libraries such as NumPy, Random, CUDA, etc. So we have to control all of them together. So in those scenarios, what I personally like to do is create a simple function that wraps the seed of all other libraries. So what I mean is I'm going to import NumPy as well, import NumPy as np and import random as well. Now I'm going to create a function set seed. And by default, I'm going to set seed to 42. Random.seed seed. And similarly, we can set random seed for NumPy as well. So np.random.seed. And same thing. Let's pass the seed value. And same thing for our torch as well. So torch.manual seed 42 and torch.cuda.manual seed, actually manual seed all and 40 or seed. Now simply call this setSeed function with the value you want. So I'm going to say 101, and that's it. Now, no matter how many times you rerun your notebook or restart your runtime, your training results will be consistent, assuming your model, data, and hardware setup don't change. Just a heads up, even with all this, reproducibility isn't always perfect across devices. GPU operations can have slight floating point differences. Threads may execute in non deterministic order, and that can cause tiny drips. But for 99% of our use case, setting seeds like this is enough. So here's the rule. When experimenting, always set a fixed random number seed and log it with your results. Because if you can't reproduce your model's behavior, you can't trust your research. And that's it for this video. In the next video, we'll explore what are datasets and data loaders in PyTorch and how data loaders work, and we'll visualize the process step by step. Till then, thank you so much for watching and see you in the next part.